Yeah, so thanks for thank the organizer for giving me the chance to present a different look on the SDV. So we started here from the vehicle perspective, and the focus, and it's a very valid focus, is the in-vehicle part, but we are coming completely from the other side. So we are from the cloud part. The cloud part has its own set of challenges and own interesting parts. So I wanted to present you and give some hints or where we might think that we can help the SDV community in contributing some stuff. So basically, who are we? We are Waldtech Mobility. So basically, we are a joint venture of Waldtech and Carriot. And we are developing and operating connected car backend systems with, I think, around 30 million connected vehicles. So I'm Jan, and I will give the talk, and I have my friend Daniel with me on stage. He's mostly interested in the business processes, and we split it in like two parts. So more technology part, where I'm would answer questions, and in the business parts, because backend software is, most of the time, a lot of to do with integrating business processes and so on. And if you have questions regarding that, then Daniel is the one to ask. So when we are doing it like 10 years now, developing such software. So what we're going to see now is what the talk is about. I'll give a short introduction to the topic, and then we go to the technical challenges and where we want to contribute, and to the domain challenges. So the SDV, in my opinion, and in our opinion, needs two parts. It has the vehicle part. Oh, sorry, you cannot really read it, but it basically says you have the vehicle part, but you always have the back end or the cloud counterpart. Mostly consists of digital twin. Backend provides updates, and maybe a shopping functionality where you can buy software and install it on the device. But, and that is a quite big but, it's you need a lot of also non-differentiating enablers to get these things going. So on the technology side, you need messaging, and you need a good messaging protocol. Currently, what's mostly used is like MQTT. There's the Zeno project here at the SDV. So there are different protocols to do it, and they all come with different challenges. And most often, operations and scaling is a little bit, or sometimes an afterthought, but we want to emphasize it's really important to think about how to scale your system before those challenges come up. And also authorization, authentication. Do you really want to go the way down and provide some certificate management, or do you want to use certificates from a third-party system? Do you want to use tokens, or how do you do that? How to integrate with your maybe OEM systems and so on. So that is kind of in the middle between technology and domains. And the domain part is you need to manage something like SIM cards, because in the end somebody's going to pay for the traffic the SDV or such a car generates. And you want to have something like APN management. Is the customer paying for it? Are you paying for it? You want to manage it, and you want not only it in the car, you will always have a car part, but you also have a backend part to manage those processes. Another thing is users. So who is the owner of the vehicle? How is the owner represented? If you want to install software, you need consent from an owner or from a user in the car. Who is owning the data the car produces? Do you have to associate it with an owner, or do you have maybe a guest user in it? And these are all domain parts which a backend needs to address. Okay, so from the technology part, we're starting there, and where we want to or like to contribute. So a backend is always outnumbered, but with the bigger machines, you can imagine. So there are 10 million vehicles in the field communicating with one single backend. Okay, we can now in the cloud horizontally scale, but you will not scale up to 10 million machines. But you have bigger ones. And the interesting part is with every order of magnitude, the failure gets, in my opinion, more interesting. But if you have more traffic, failure with a low probability will happen. And you have to be aware of it. and Werner Vogels from Amazon, gets it completely right. And when he says, everything fails all the time. So you have to make sure that you can handle the errors which will come up in this or at this scale. And there are some scenarios which are not so common, and you only see it, or they only really matter when you have lots of vehicles connected. And therefore, I will say, or we say that considering those failure scenarios and the reliability in the messaging protocol is as important as throughput, latency, and efficiency. And most of the messaging protocols, they have papers about how many data they can process, how many messages. It's all well and super cool, but it's also important how to handle certain failure cases, especially when sudden events like disconnect events happen for a lot of clients, or state mismatch or something like this. And in the next few slides, I will show some of those failure scenarios you have to consider. The first one is quite obvious. If you have a big fleet connected to a cluster, so we are looking at think MQTT or clustered publish-subscribe protocol, you have a whole fleet connected to it, and on each node you have like 500,000 connections, it could be even more, and then your network fails. Not directly the network, but normally you have persistent TCP sessions, so it's enough that through some maintenance operation on the MNO side, the TCP connections get cut. Not only the complete mobile sessions. And then, what happens? The cards, they don't know about each other. They will try to reconnect, and you get a reconnect storm because they all try at the same moment to reconnect to your cluster. And so those 500,000 connections, I pointed out, so I moved the green line to the others, but normally it should be more like a rainbow color because those 500 connections get spread out over the whole cluster. And in a cluster, you don't have topology changes there, but you have to handle the reconnect. And especially if you have state, you need to transfer state, like when is this connection associated to node A or B, and when it disconnects, it goes to node C, and maybe you have to move messages around, and you have to prepare for that. If you do it in a naive way, or if your protocol doesn't consider it, or you didn't test it, you will have problems. I'm pretty sure you will have problems at a scale of like 500,000 or 1 million connection per node. And an SDV needs a stable messaging system, right? Because if you want to do some commands or the user expects that it works nearly all the time, then such a mobile outage, it will be an outage for sure, but you have to make sure that the time to recover is quite, that you lower the time to recover, or have it in a shorter way. And if such a connection or the reconnect storm kills your whole cluster, then you have a problem. The next thing is, so to speak, it's a little bit different, but a small version of it. So you have a single node outage. You also have the reconnect, but with a node outage or a single node which fails, and you have to prepare for that, you have a topology change. So you need time to detect the node loss, and you need also the message synchronization. And that is the MNO outage is quite improbable, but this you normally have to do on a not daily basis, but maybe weekly when you want to update such a node. You might do it like take it out and then the cluster resync and put a node back in, or you spin up a new node, let the cluster with those are 6 with 7 nodes synchronize itself, then take one out. There are many processes, but your protocol or your implementation has to deal with that, and you have to, it has to work with taking a node away and spinning up a new one, and so that the cluster synchronizes itself. Those things are quite interesting, but it gets even more interesting, and those are sometimes interconnected because with some failing nodes and failing synchronizations in cluster protocols, you might come to state mismatch. What do I mean by that? So maybe we saw those things on live environments. So the car might think that it has a session, so most of those protocols are quite stateful, and it is subscribed to some MQTT topics. But on the other side, the the cluster, which has also some state, thinks, okay, it has a session, but the session is empty, or there's no subscriptions. There might be a bug in the vehicle which tries to start a clean session and forgets to resubscribe, or there are lots of possibilities how this setup can happen. But now you have, like, when you publish something to you do some important command to the vehicle, and there is no subscription, the message is just discarded in the most protocols. So it basically goes to dev null, and you don't really see it. And in MQTT, there is no detection or no resync mechanism for self-healing. Like, you are in this situation, and how to come out of it. You can invalidate sessions, but you have to detect this failure state, or you can reboot, but from only looking from within the protocol is quite hard to handle this situation. And it happens, or we saw it happening. So coming from that, what would be our contribution, or what we would like to contribute, is to develop realistic test scenarios for protocols which are used in this SDV community, like the Zeno protocol. I would also like it for MQTT or NUTS.io or whatever is used for some messaging protocol. I would like standard test cases covering more interesting scenarios. There's this list of tests, like the consistency test with the Jepsen tool, where they are testing messaging protocols, Kafka, Cassandra. They even found consistency bugs in Postgres, which is quite interesting. So I would like to develop, or to help to develop, those test cases for those protocols. I also would like to have some formal methods in there, but that is a personal thing. Don't put it on the slide. So TLA plus or so, modeling those protocols would be very nice, but okay, to keep it realistic. There was a technical part, but we also have the domain challenges we would like to contribute. And those are, as I mentioned, like the SIM card management. You want to do something like shipping modes. So when your car is for a different market and you don't want to start the traffic from the car or the online, the mobile connection or the data downloads when it has the standard profile, because it's quite expensive. So you need something like the shipping mode, and that is most often done via backend processes. And those SIM card management things, they are, in my opinion, you need it, and one could develop something which is, so to speak, non-differentiating and can be used for different OEMs. So why do some OEMs need to develop such things themselves? The other thing is like APN selection. Then if you have different brand countries, so how is something like brand country management integrated in the SDV? Currently, I don't know, but maybe it's interesting. So when you need different variants, you have to have some backend processes managing those. Also, like Verbauzustände, so which applications can be installed on which hardware. I know it's always about the reduction of complexity, so having a single, that would be a dream, I guess, a single setup where you can say you can install nearly all the software, but to be honest, I don't think that will be the case. So you need some way to manage like what is installed in the car, what is the car capable of, and have it connected to some update processes or update management processes. Last thing, or not the last thing, but it's like a user consent for updates, consent for installation, who owns the data, personalization. There is this nice piece of software, or this nice where you have this seat adjuster. So basically it moves the seat to a setup predefined, but normally you want such things personalized. You want to know that a user is now in the car, has logged in, and then load the data of the user and then apply this mechanism or other personalization things. So in our opinion, it's quite important to have a concept of user integrated to it. And that is what we would like to contribute. It's like a blueprint, or not directly a blueprint, but take the seat adjuster code and put a user login in front of it and have this synchronization personalized. That would be our contribution, or where we'd like to work on, and maybe define a concept how to integrate some things like a user in this whole SDV ecosystem. Other things would be like looking at those business processes and where could we contribute. But at the first start, we think that a user would be great to have and to integrate. And the other thing on the technology side, we would like to help the protocols in here with a consistent set of test cases, and with our knowledge on what we know, what can fail and what will fail, to have a very resilient protocol and a good basis for the SDV. And that would be all of it. And I would like to say thank you for listening for the cloud perspective.
Thank you. And we'd be extremely happy for you to contribute. And maybe one place to start would be to join the discussion around the protocols and the communication protocols in general. But is there any question from the audience? Yes, Kai.
Thanks a lot. I was wondering if you have any experience with other OEMs, whether they are actually building such a backend themselves. Depending on who you talk to, if we ask our friends from Microsoft, they say, well, you should simply connect to Azure IoT and that's it. If you ask others, they don't want to. Do they actually build their own backend? Is that your experience, or are you building your own backend?
It depends on what's the scope of backend. So we are not developing the MQTT broker, but we're developing mostly the part that lies behind the MQTT broker or the backend connecting to it. What we also develop, okay, it's an older system, like when you think about the Amazon part, so you have incoming messages, and what you all need to do or always need to do is kind of route messages and enhance messages. For us, it's HTTP calls with some context information like engine codes or so on. Those kind of dispatching systems that are built by us. But we're not building directly the MQTT broker. But all the other processes behind it, so connecting to the OEM Konzernsysteme, don't know what's the English word is, and getting like the metadata of the cars and integrating and calculating what the cars can do, and like license management and so on, that is built by us. And I don't think that you can buy it just or click it from Amazon or Microsoft. The IoT broker, for sure, the routing part, for sure. It would be very interesting to see how some like this Jepsen tests or chaos testing is done on what the results are on those IoT Core or Azure IoT. I don't know. It's IoT Core and the Azure and the AWS protocol. I hope that answers the question.
Yeah, thank you.
So, any other question?
Is there any specific protocol that, like, you have preferred, which is more robust against, like, this kind of failure that you explain? Is there some kind of investigation to that? What kinds of protocol do you work with?
It's just a personal answer. I quite like MQTT, but I think the clustering of MQTT is quite hard, because in MQTT you have a connection to a node A, but you have no association from the subscription to the device. So you can publish on a completely different node, and it has to be routed to this one connection. And also it might get routed to more than one connection, because a lot of devices can subscribe to the same topic. It would be, and in my opinion, it would be better suited for the SDV when you have a directly backend when you can directly address device. So you don't need to route through the whole cluster, and you don't need the state to know where is all the where the connection lies. You can look at it from maybe the topic, and then you know this VIN is, or this device is connected to node A, and it can directly publish it there. I don't know if there exists a protocol. I think when you in the SDV space look at, it's not directly the protocol, the HONO implementation, they kind of do it like this, but there's also a distributed cache, which, but yeah, I personally like MQTT, but I also like the good old school HTTP calls for synchronous communication, so a mix is good, but I have the most experience with MQTT. Other protocols might be as good.
All right, thank you.
Question from Daniel. And then...
Hi, thanks for the presentation. Just like the obvious question for me, have you already had a chance to look into the U protocol project, and or are you interested in having a chat about that? Can do that in the break if you want to.
The U protocol, I looked at it, but not in the detail I would like to. I would have, yeah. And I would really like to have a chat about it.
Let's
I
do
really
that,
like
yeah.
to compare those.
It's probably not an off-the-shelf fix for everything that you need, but it does definitely touch a lot of areas that you have touched on.
Oh, okay.
And to be very frank, my personal view on where this community is and where we need to go, we have this project there that is production code by a relevant OEM in the world. If we can get any piece of our portfolio to be used by more than one entity, you know, then we have the milestone as the SDV working group, and that's why I would like to have a chat with you about that.
Yeah, for sure.
Right.
Yeah, and that the discussion that I hinted at the beginning, that we have a very large group of people communicating around U protocol in general, communication protocol. So please do join that. And one question from Nicolas. And then I think we have to move on.
I will be really quick. We're working a bit on the same, we did exactly the same basically, but for another. I have a question regarding data ownership protection, knowing that, for example, if you deploy in China, they're not supposed to leave China. US, same thing now, and that's add to complexity on this thing, no, I guess. Something.
Yeah, if you have local data restrictions, it always gets more complicated. And it gets really more complicated if you have to build different backends or deploy different backends on different paths. And if they have to synchronize,
Yes,
then,
exactly.
yeah, there's always more complexity.
Okay, I just checked and no questions from the online audience. So thanks a lot.
You're welcome.
And,
Thanks.
and we need to move on to the next speaker. Thank you. Thank you.